So before I jump into the topic of this video, I wanted to show you a quick view from the fifth level, which is technically the third story above grade, but it's the fifth level of this 48-foot tall multi-generational passive ICF house that I have built. So check out this sunset. I mean, the views from up here are just absolutely stunning from this third floor. So and then also let's check out the views, because I did say it's 48 feet high, and yes, from there up to the top is 48 feet. So you don't want to fall. You definitely do not want to fall. But what I wanted to share is just what are some of the basics that go into doing a DIY ICF build. And falls are one of the things that people are really worried about, and I don't blame them. I mean, that's a long way down, as you just saw. And so one of the things that you need to understand is that when it comes to stacking your block and building your block, it's all done from the inside. And I'm going to show you how I did that with the scaffolding that is also part of the bracing as well. So the highest that I was ever on the scaffolding was maybe 10 feet above the floor level. And so if anyone has a fear of heights, you don't have to worry about that much so much. Getting out here on this, as you're putting in, I'll teach you what that build buck is. That is a little bit frightening because you're standing there, and so I would suggest you go ahead and invest in some fall protection. You're going to need it for the roof anyway, so you might as well get it. Yeah, so that when you are having to stand up here and put in your bracing and put in your window bucking, that if in the unlikely event that you do fall, it won't be deadly. So that's a little safety tip for today. All right, so let's talk about what is ICF. So let me grab one of my blocks, one of the smaller blocks. Actually, I can grab the big block too, but the smaller block is a little bit easier to show you. So this is an ICF block. It stands for insulated concrete form. And so normally when anyone pours like a concrete basement, they use these wooden forms that they reuse over and over again. Well, this eliminates the need for those wooden forms. And there's a number of benefits of these ICF blocks because they stay behind once you're done pouring the concrete. So one of the benefits is you'll notice along the edge, both edges, that's 2.5 inches of foam. And that's pretty significant because this comes with all of your insulation already installed, all ready to go on the inside and on the outside. More importantly than that, in between, so you can see right here, I have 8-inch concrete blocks. So my blocks are filled with 8 inches of concrete, and in my case, over 1 million pounds. So over 1 million pounds of concrete flowed through my hands as I was holding that concrete hose from the concrete pump truck. And so let's, I should also mention, so what are some of the other basics? So yes, concrete goes in. The good news is, no, you're not doing it in 5-gallon buckets. You pay for a concrete pump truck. In my case, it was about $700 or so for them to show up. That got me 2 hours. And then it was $100 and some odd per hour after that. And they charge like $2 or $3 a yard. So I did a total of 6 pours, and I'll explain why I did 6 pours. And each time it cost me about an average of $1,000 or more, just for the concrete pump truck. But it is 100% worth it because you're not going to be doing 1 million pounds in those 5-gallon buckets. That's just not realistic. The other major component that goes into building an ICF house is rebar. So I lifted it by hand, all of it except for a little bit up at the top. 20-foot sticks of rebar, number 3, number 4, and number 5. And I actually had to do some number 6 rebar as well. So the rebar is obviously a critical component of any ICF home. Structural engineer isn't going to let you get away without it. I am living in earthquake zone. So these mountains, I don't know if you can see the mountains there and the mountains there. Yeah, so I'm living a couple miles away from a significant fault. So for me, I had to actually do 8 inches of concrete all the way from the ground, all 48 feet. There's other people in where you're not in earthquake country, where you're able to transition over to 6 inches pretty quickly. So let's talk about my rebar, my personal rebar schedule. I know that in other parts of the country you don't have to put in as much rebar, but because I am in earthquake country, I did have to put in a little rebar. So the horizontal rebar snaps in, show you that, snaps into these handy dandy ties every 16 inches. And these blocks are 16 inches tall. So you stack a block, you put your horizontal rebar, and I highly recommend that you go ahead and invest, if you're going to be doing something as big as I'm doing, invest in an electric rebar bender, because you're going to be bending a lot of rebar. And you're going to be cutting a lot of rebar, and it does both. So mine cost me, I don't know, a couple $1,000, but it more than paid for itself, because above the windows on your load-bearing walls, you're going to have to put in these things called stirrups, which is basically just bent number 3 rebar, or whatever your structural engineer calls for. So you've got your horizontal rebar that you have to put one row on, one stick all the way around on each horizontal set of blocks that you do. And then after you get done stacking all of the block that you're going to do for that particular pour, then you drop your vertical rebars in. And for me, my structural engineer called for a vertical rebar every 12 inches. Another place that you end up putting a lot of rebar in is around all of the edges. Every single opening, you've got to put 2 pieces of vertical rebar going up here, 2 pieces of horizontal rebar going at the bottom, and then same thing over on that side, and same thing above. And wherever it's a load-bearing wall, you have to create what's called a lintel, and you end up doing another 2 pieces of rebar above. And depending on how wide your windows are, so if they're narrow windows, my structural engineer just called for 16-inch tall lintels. If they are really wide windows, like I have some 10-foot wide windows, then those ones called for a 36-inch tall lintel, which basically meant I was bending my stirrups at 32 inches. So that's just something else to be aware of in terms of the rebar. Another thing that I did that was helpful on my particular build is I'm 72 feet by 34 feet. And like I said, it's 5 levels and it's 48 feet tall. When you're spanning 34 feet, technically you're not fully spanning that, because your joist hangers are on the inside. But nonetheless, it's a long span and there's a lot of deflection. And so to mitigate the deflection, I ended up going with a post and beam, and I went with 15-inch glue lam beams that you can see up there. And then I went with metal posts. Now, I decided, what it was is initially I thought, I'll just go with wooden posts, because I have the skill set to deal with wooden posts. I can use a chainsaw, I can use a skill saw, and I can screw in bolts. But I quickly realized, dealing with the width of those wooden posts, I do have them down in my crawl space. But I decided that once I got above the crawl space, I switched over to these steel tubes. So down in the basement level, because it's carrying so much weight, those ones are 6-inch, but then we were able to quickly transition over to 4-inch. The nice thing about the 4-inch is my wife was able to design all the rooms in a way so that in basically every single instance, nobody's ever going to know that there's any of these metal posts in here, because they're all hidden inside of walls. And we also designed the house. I wanted to have as few load-bearing walls as possible, because this is a multi-generational home, but I plan on being in the family for at least 500 years, and I want future generations to have the flexibility to redo the walls however they want. When it comes to the window placement, they're kind of stuck in concrete. Not necessarily. I mean, they can always cut, but yeah, they get to enjoy where we chose to put the windows. It's one of the most stressful things for my wife, is deciding where to put the windows. All right, let's talk about some of the other tools that I used on this 48-foot tall DIY build. So absolutely critical, get yourself a good long level. You'll be using it to plumb up your walls after you pour the concrete. Actually, you pre-plumb them, kind of, and then you do the final plumbing after they're filled with concrete. One little tip on that, and that is when you stack your ICF walls, it's super easy with your bracing to pull it in and out when it's empty. Super easy. And so, but when they're filled with concrete, it's really, really hard to pull that wall back in. Like, you may end up pulling your plastic tabs out. And I should tell you a little bit about the plastic tabs in a minute. But it's actually pretty easy to push walls filled with, in my case, 1 million pounds of concrete, not all at once, but it's pretty easy to push the walls out. And so by having it and what I would do is I would use the level and I would touch the bubble to the inside so that you could see that it was tilted inside. And then a lot of times when it got filled, it naturally just pulled itself out just right, and we wouldn't have to do a lot of twisting on the turnbuckle, on the bracing. I did say I should mention about these plastic tabs and the plastic webbing. So you can see right here in between, that's what keeps this whole thing, which is pretty amazing, keeps the whole thing from just exploding out when it gets filled with concrete. The other benefit is because it stays in place, it has a plastic tab. Everywhere that you see this, I can screw in, and it's the equivalent of screwing into a 2x4 in terms of the pull-out. And everywhere that it has this special little mark called BB, that's actually a 425 or so pound pull-out. So pretty impressive. I'll be able to mount my kitchen cabinets directly to the foam. So let's go back to bracing. Let's talk about the bracing, because that's another one of the critical components. If you want to do, and please brace right. I mean, I cannot tell you how embarrassing it is when inspectors tell me about all of these homes, even that professionals do, that have these wavy walls, especially DIYers. The concrete guys tell me it's just remarkable, miraculous that a DIY guy was able to get 48-foot tall straight walls. Straight and plumb walls. When other people who've done ICF, they're just amazed. You can do it if you brace it right. And when it comes to bracing it right, you need to get enough bracing equipment so that you're able to brace it. And I know that this is overkill, but I ended up with straight walls. And a huge shout out to my ICF consultant, Jeremy Anderson from Green Building ICF Solutions. He taught me all of this. And I would highly recommend that you get yourself an ICF consultant. Don't try to just YouTube this on your own, because once the walls are filled with concrete, they're not going anywhere. It's set with concrete. So here's the basics of bracing. This is called a turnbuckle, and that's what is set up. And you can watch some of my other videos on how I teach you how to do it. But basically, that makes it so that you can pull and push your ICF walls. These guys are the scaffolding, so that's for your safety. That's for your 2x4s to go across so that you don't fall. This is what holds up whatever I use 2x12s for my planking. And then over here, let's go over here. This is the real magic. So that's aluminum 10-foot bracing. And I would screw it in every other hole, and it gets screwed in to the wall. Gets screwed into the wall when as you're going up, and then you attach your scaffolding to that. You attach your turnbuckles to that, and I did it about every 4 feet, every 4.5 to 4 feet, and that's really how I ended up with such straight walls. Let's see. Let's talk about some of the different options. I actually ended up using 3 options for connecting my my open web floor trusses into my ICF for connecting 2x12s into ICF. I use two different options. And so one of the options is called a Watkins hanger. This is a slick system. I mean, it really is super easy. You just watch some of my other videos and you'll be able to see how I cut and put it in the rebar. But you can see how it just goes in like that. It makes some cuts, slides in, the rebar goes through there, and then once it gets set up with concrete, let's see if you can see one of them. So you can see how the open web floor truss just sits down in there, and then I'll end up screwing it in so it becomes one solid unit. So that was one of the hangers that I used. Another hanger that I used is what's called a Berman hanger. Berman hanger, once again, it's a really slick system for attaching. They actually do have versions that you can attach open web floor trusses, but I used it for their ledger hanger, and it was basically, it's this piece of metal. This is the part that actually goes into the ICF wall. Before you pour it with concrete, if it's on the inside, technically you don't have to put rebar through these little holes. The manufacturer says, they're engineers, I'm belt and suspenders, I did it anyway. On the outside of the house, for sure you have to put the rebar through it. And then after you get done, pouring, then you use this little template to know where you're going to drill holes in order to attach this screw right here. So you can see how this long screw is going into the short screw. The short screw is already in the ICF wall when it's poured to concrete. I don't have any J-bolts with me, but I also did the J-bolt method. Maybe I'll do a video where I compare and contrast Watkins to Berman to J-bolt. So let me know down in the comment section if you want me to do that compare and contrast, because I did all three on this particular house build. Let's see. Actually, it really is as simple as that. So the first time that I saw an ICF block was when the semi truck that was completely filled to the brim pulled up. That was the first time I ever held an ICF block or saw an ICF block. And as you can see, this one's a 4 foot, so they come 4 feet, 16 inches. It weighs a total of 7 pounds. So I've had little nieces and nephews as young as 2 lift it up and help me to stack it. This is the corner block. Corner block is where you make or break the blowout situation. This is where most people's blowouts occur, and partially you can see because there's not as much webbing here. So one of the secrets to not have a blowout, I didn't have any blowouts that were caused by the ICF product, 0. So two things to bear in mind is when you are filling these with concrete, go straight down. Have that hose going straight down. You'd be shocked at how much pressure is coming out of that concrete when it's being pumped. So straight down. When you get to an edge, stop right here. Let the concrete just slowly fill in over there. Don't ever blow down in this area, or else you might have a blowout. The other one that you have to be really careful of is your vibrator. I can't tell you how many people, fortunately I had 0 problems with the vibrator, but that vibrator is having to make its way through all of that rebar. And if it goes off at an angle and punches a hole, then you've got a blowout, and now you have a problem. If it's on the inside, no big deal. You just grab a ladder. I mean, like if it happened right there, no big deal. If it happened on the other side, I mean, yeah, that would be bad. To have to be out on ladders, to have to somehow be trying to patch on the outside, that would be a total complete nightmare. So I'm hoping that this little quick overview of what ICF is, what are the components, as you can tell, it's actually a pretty darn simple system. I should show you how easily they stack it together. So when people say it's like stacking Legos, it's like stacking Legos. And let me get the camera so you can see. So you line up the teeth, and it already slipped in. And then I've also shot some other videos about how I use foam. so that I didn't have to deal with the dreaded winds knocking down my walls. That never happened to me. Also, there's other benefits in terms of uplift. Let me see if there's anything else I wanted to share with you. Yeah, so bracing your windows. So you need to leave, however you brace your windows, you need to leave those up for 28 days to let your concrete cure. So I'm 2 weeks in, I still have another 2 weeks to go. I'm probably gonna let these stay in for a lot longer than that. I don't know if you can tell it, it's freezing. I mean, my fingers are popsicles right now. But that's one of the sacrifices that you need to make if you are going to DIY, is you need to be willing to put that headlamp on, stay at night. You need to be willing to get up in the morning. Be out here next Tuesday, it's going to be down to like 105 in the summer. Also, I should tell you about this buck system for the windows. So you have a couple of options to buck out your windows, because you obviously don't want the concrete to be pouring out. So you can buck it with 2x12s. One of the big downsides of 2x12s is that you have what's called a thermal bridge. So all of your heat in the winter goes out through that wood, just like a bridge, and all of your heat in the summer comes in, and I didn't want that. So I paid extra for what's called build buck, and you can see it around my window edges. Let me pick up a piece so you can see. I didn't have much scrap. I mean, you're looking at my scrap pile after what? This is my 5th level. Granted, the crawl space doesn't have any windows, but I have a bunch of windows in the basement and a ton of windows in the 1st, 2nd, and 3rd floor. And so I didn't have much scrap that was left over, which is good because the stuff isn't cheap. But it's a thermal break, and so the heat isn't able to go out in the winter, and the heat's not able to travel through this foam in the summer, and you're still able to screw your windows into it. So let me know down in the comment section if you have any questions about this crazy adventure that obviously I'm still on. Need to put my roof rafters up, need to get the roof on before it starts to snow. So let me know if you have any questions, and if not, thanks for watching.